Alright class, we're going to look at this problem from your 3.4 homework set, and we got a distance formula that's given right here, and we want to know how long will it take before this thing reaches a certain speed. Okay, this is measured in meters from the starting point, alright, and then this is this many kilometers per hour. Okay, t is measured in seconds. D is measured in meters, okay, and its speed is 200 kilometers per hour. So you're going to have to do a couple of things to be able to answer this. Number one, you gotta make sure your units are always the same when you do problems like this. So 200 kilometers per hour, that's 200 kilometers divided by, well, sorry, let me do it this way, divided by 1 hour. Alright, and we need to get it into meters per second for the units here. So I'm going to multiply that by, in 1 hour there is 60 minutes, and in 60 minutes, or in each minute there's 60 seconds. So that's 3,600 seconds. Alright, and what's going to happen there is these hours are going to cancel, and we're going to be left with kilometers per second. Okay, and then I'll also want to get meters instead of kilometers. So I'm going to need to multiply this thing by, in 1 kilometer there are 1,000 meters. Okay, so my conversion that I need here to get from 200 kilometers an hour to some amount of meters per second would be this product. Okay, this is just conversions, canceling out your hours, canceling out your kilometers, and what you're left with is meters and seconds. All the other units cancel. So what we're going to end up with here is 200 times 1,000. Alright, and then all of that divided by 3,600. So there is the number of, there's the speed that I want to get measured in meters per second. I'm going to call this S. Okay, now that's how fast we're going in meters per second. But this is distance traveled. So to come up with how long it takes to get to that speed, I need to take the derivative of this. The derivative of distance is velocity. So we need to take the derivative of this formula right here. So that's going to be 20/9 t, and we're needing to set it equal to our value for S right here, right? This 55.55. So there's a couple things you can do. Number one, with Desmos, all I'd have to do is like write this equation, y equals 20/9 t, and I'd have to write y equals what I got for S. You could also write the 55.5 repeating, but y equals S. And since that is 55.5, I'm going to need to adjust my window to be able to see it. So 0 to, let's do 60 so we can see the intersection. And our time starting from 0, it's taken more than 10 seconds. Let's look at 30 seconds. And that intersection is now in the window. Alright, so at 25 seconds, I get up to that speed. Okay, this green curve is our velocity function. Okay, I'm using y equals, it's technically v equals for our velocity, but it's just the derivative of this. The derivative of distance is velocity, and the velocity is giving our speed. Okay, we just need to convert our speed to meters per second instead of kilometers per hour, because that's the units that D measures. We got to make them consistent. So 25 is the x coordinate here, so that's my answer. Now it wants to know what distance did it travel. Well, that means we're going to take 25 and plug it back into that distance function. So the distance function is d equals 10/9 t squared. Alright, it's just that we know t is now 25. Alright, so there is my answer. It's given to me in a decimal approximation, and it wants an integer or a fraction. So you just square this. That's 625 is that number. And then 625 times 10 is going to be 6250 is that number. And just notice we just keep getting that 69.444. Alright, so there's our number, 6250 over 9. Alright, but in these problems you just got to remember a couple. The things you have to remember is the unit conversion if your units don't match. Alright, and then distance, the derivative of distance is velocity. And velocity, the absolute value of velocity is speed, but it's positive here because we're moving forward and we're increasing speed. So that's what you have to do with these types of problems. Take the derivative of this, set it equal to this, but only equal to this after you've adjusted your units.